let's do the next problem. In how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? Now see here what we have to do is, let us consider this word, okay? It has how many M? Only 1, right? And S how many are there? 4 are there. I repeats 4 times and P repeats only 2 times, right? So 2 times. Total how many letters are there? There are 8, 9, 11 letters, right? So in this 11 letters, what we have to find out? We have to find the permutations where 4 I's not come together. What we do is, to find the permutations where 4 I's, this I, 4 I's are there, no, they don't come together, we find we find the total number of permutations and subtract, from that we subtract the permutations where these 4 I's come together. That time we will get the permutations where 4 I's do not come together, okay? So that concept we are using here. So let me find out the total permutations, okay? Total number of permutations is equal to, or permutations of the word, okay? Permutations of, in the word, or of Mississippi, this word Mississippi. This is very important question, okay? Mississippi is equal to, now see, total how many letters are there? There are 11 letters. So it is 11 factorial divided by, because some of them are repeating there. So M is only 1, so you need not divide by 1 factorial. And S is 4 times, so you have to divide by 4 factorial into, again this is 4 times, I is 4 times, you have to divide by 4 factorial. P is 2 times, so it is you have to divide by 2 factorial. And simplify this. 11 factorial divided by 4 factorial into 4 factorial into 2 factorial. You will get this is equal to 24,650. Okay, this answer you get when you simplify this. Now see, this is not the required one, isn't it? We have to find the permutations where 4 I's do not come together. So total we got. Now we find the number of permutations. Now number of permutations where 4 I's come together. Okay, permutations where 4 I's come together is equal to, okay, this is equal to what? Now see, we have to consider this with the 4 I's coming together. If 4 I's are together, okay, this forms as a 1 unit, correct? This forms as 1 unit. Now what is remaining? Remaining 2 P's are there, 4 S's are there and 1 M is there. So remaining M, 2 P's and all 4 S will be separate units, right? So total how many are there? 1, 2, 3, 4, 5, 6, 7 plus this 1 unit. All together we consider this as 1 unit. So 1 plus 7 we get total 8 units. So total there are 8 number of units, right? So we take 8 factorial divided by, again in this, see this is considered as 1 unit. So even if something repeats inside this, we cannot consider in the total, right? So this is 1 plus 1, there is no repetition. Again plus 1, but here you see P is repeating 2 times. So we have to divide by 2 factorial. Into, again S is repeating 4 times. So we have to divide by 4 factorial. Into, again inside this, we have to find out what is the number of permutations inside this 1 unit. Now see there are 4 units here, right? 4 separate units. In that, all those we cannot, if I interchange the position of these, okay? If I interchange the position of this, can you make out the difference between the arrangements? Not possible. So here different arrangements cannot be distinguished, right? So we write the arrangements here is 4 factorial divided by 4 factorial, because 4 units are there, so it is 4 factorial divided by, it repeats 4 times, so it is divided by 4 factorial. So inside this we cannot make out the difference between the different arrangements, therefore you need not multiply them. If you multiply, so you have to multiply by 4 factorial divided by 4 factorial because of repetition, okay? So if you don't write also not a problem, because you cannot make out the difference between the different arrangements inside this 1 unit, okay? So this will be the answer. So simplify 8 factorial divided by 2 factorial into 4 factorial, you get the answer as 840, okay? This is about the permutations where 4 I's come together. But what we require, the permutations where therefore at the end, right? The permutations where 4 I's do not come together, okay? 4 i's do not come together is equal to what? Is equal to total number of permutations, okay? Total permutations minus permutations where or arrangements where 4 i's are together. Where 4 i's are together, right? So what is this equal to? I'll write it down, okay? So this is equal to, we got total permutations is equal to 34,650 minus 840, okay? When you subtract these two, you will get the answer as 33,810, I think, okay? So you get the answer as 33,810 as the required number of permutations, okay? So practice this properly, students, because these are important questions in the exams, okay? Let's move on to the next one. In how many ways can the letters of the word permutations be arranged? If the first one, word starts with the P and end with S, okay? See here, we have to find out the number of permutations of the word permutations. If the first one, the words start with the P and end with the P, okay? If the word start with the P, it is fixed here in the beginning, and end with the what? Yes, right? So S is fixed. In between, how many letters will be there? See, total how many letters are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 12 letters are there. In that, these are fixed, right? First and last will be fixed. How many remaining letters are there? 10 letters are there, right? Remaining there are 10 letters. Therefore, the number of permutations, okay? Number of permutations, required number of permutations is equal to what? Permutations is equal to, see, there are 10 letters which can be arranged in 10 factorial ways, right? In that, anything is repeating? Yes. T is repeating 2 times, isn't it? Any other word is not, letter is not repeating. Only among this, T repeats 2 times. Correct? Only T is repeating 2 times, though. Therefore, 10 letters among that T repeats 2 times. So 10 letters can be arranged in 10 factorial ways divided by 2 factorial, because T is repeating 2 times. So you divide this, you will get 10 factorial divided by 2 factorial is equal to 1814400. Okay. So this is what answer you get for this number of permutations. Okay. Now the second one. What does the second one say? Vowels are all together, right? Vowels. How many vowels are there here? See, E is a vowel. E, U, A, I, O. Remaining all are consonants, right? So I'll write that together. E, U, A, I, O. These are the vowels. So all the vowels occur together. Therefore, this is considered as one unit. Remaining, which are there? P is there, R is there, M is there, T is there, 2 times T is there, right? Then I, O, N, S, N, yes. So these are the remaining units, correct? So here it is 1, 2, 3, 4, 5, 6, 7. This together is considered as 1 unit. So total there are 8 units. Therefore, the required number of permutations you can take as required number of permutations is equal to. So how many total units are there? 7 plus 1, 8, right? So it is 8 factorial divided by. Is there anything repeating here? This plus, this is 1 unit. Whatever is repeating here, you should not consider, even if it repeats. Okay. Here T is repeating 2 times, so we have to divide by 2 factorial. Okay. Now inside this 1 unit again some arrangements are there. In that case we did not consider because inside that whatever is there are not distinct, they are same. So you cannot make out the difference between the different arrangements. But here all the letters inside this are different. So you can make out the difference between different arrangements inside that, right? So inside this also there are different arrangements. Which are those? See, there are 5 letters. So 5 letters can be arranged in how many ways? 5 factorial ways. Anything is repeating there? No, nothing is repeating. Therefore, divided by anything is not there. Okay. So 5 letters can be arranged in 5 factorial ways. So by FPC, this is one of the arrangement. This is one more arrangement though. Therefore, total number of arrangements is First one into second. Okay. Now simplify this further. You will get this as 8 factorial into 5 factorial divided by 2 factorial, which is equal to 2419 200. This answer you will get when you simplify. Okay. That is about the second. Now third one you see. Third one is what? There are always 4 letters between P and S. See, they are not telling P is exactly fixed somewhere or S is fixed somewhere, right? But condition is that wherever P and S, wherever they are there, but there should be 4 letters gap between them, right? So let me consider first letter P and the second after 4 letters S should come, or first letter S and after 4 P should come. That also is possible. They did not tell first P only should come then S. This also can be also possible, right? P, S here, P here. The thing is there should be 4 letters gap between those two, right? And see here 1, 2, 3, 4, 5, 6 is done. Total how many letters were there? 12 were there. So here 6 places again left out, right? 6. Now see, this is one of the possibility. Here P is there in the first position. It is there in the 5th position, right? Oh, sorry, 6th position. Okay. Now see, suppose P is there in the second position. Okay, second. Then after 4 letters gap, S will come, right? So S will be in the 7th position. So if P is in the 3rd position, then S will be in the 8th position, right? Like that. If P is in the 4th position, then this will be there in the 9th position. Then here, 5th, if it is there in the 5th position, if P is there in the 5th position, then S will be there in the 10th position. Then if P is there in the 6th position, then here it will be in the 11th. And if P is there in the 7th position, then it will be in the 12th position. So different arrangements like this you can see. Okay. Now see, here there are 2 possibilities, right? Either S here, P here, or P here, S here. 2 possibilities. Again in this case 2 possibilities. Again in this case 2 possibilities. Because once I consider P here, S here, and one more time I consider S here, P here. Okay. So there are 2 types of arrangements there. And here also there will be 2. Here also, in this case also. In this case again. In this case. So total how many such arrangements you can get? 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. Right? 7 into 2. So you get 14 such arrangements. Right? 14 such arrangements you can get. Okay? 14 arrangements such we will get. Arrangements. Okay? So in that 14 such arrangements, see, we are fixing only the positions of P and S. Remaining letters we are not fixing any position there, right? We are changing the positions. So how many will vary their positions? P and S will be fixed in wherever you fix that, right? First and 6th position either P is there, S is there, no problem. Remaining 10 letters can be arranged in how many ways? Remaining 10 letters can be arranged in 10 ways in all the cases, okay? In all these 14 cases, remaining 10 letters can be arranged in 10 factorial ways. Among that, T is repeating 2 times, right? T we are not taking here, so T will be in between this. So T is there 2 times, so we have to divide by 12 factorial, okay? Into how many such arrangements? See, 10 factorial by 12 factorial is for remaining letters, right? But for P and S total, how many arrangements are there? There are 14 such arrangements. So we have to multiply by 14. Okay. So therefore, alright. So here 14 arrangements. Okay. Therefore, the required number of permutations is equal to this 10 factorial divided by 2 factorial into 14. Simplify this. Anyways, you will be having 10 factorial divided by 12 factorial as this. Multiply this by 14. You will get the answer as 25401600. Okay. Try this problem by yourself and try to get the answer. Next problem. Find the number of arrangements of the letters of the word independence. In how many of these arrangements do the words start with P? The second one do all the words occur together, and third one do the vowels never occur together, and the fourth one is do the words begin with I and end with P. Okay, now first let us see the first question. What is that? Find the number of arrangements of the letters of the word independence. So first is not these sub-questions. First we have to see the total number of arrangements in the word independence. Okay. So in that, how many I are present? Only one. Then the N, there are 3, isn't it? Then D, there are 2. Then what about E? E, there are 4. Correct? Then I is done, N is done, D is done, E, P. How many P are present? Only 1, right? E is done, N is done, D is done, E is done, N is done, C is not done, right? C is 1. So total how many are there? 4, 6, 10, 12 are there, right? 12 letters are there. Therefore, what is the total number of permutations? So total number of arrangements or total number of permutations of the letters, permutations of the word, letters of the word with an independence is equal to what? Is equal to 12 factorial divided by, because 12 different characters are there and divided by what is repeating. N is repeating 3 times, so you have to divide by 3 factorial. Then D is repeating 2 times, so you have to divide by 2 factorial. And E is repeating 4 times, so you have to divide by 4 factorial. So simplify this: 12 factorial divided by 3 factorial, 2 factorial, 4 factorial. So get the answer as 1663200. Okay, that is 16,63,200. You will get. Check the answer once. Okay. So this is about the total number of permutations. Now see what you have to find. The total is done. Now let us go to the first sub question. So first sub question says that do the words start with the P? See, starting with the P means it is fixed, right? So there are 12 letters. In that P is the starting letter. Remaining 11 letters, right? Remaining 11 letters are changing their positions. Only P is fixed in that position. Therefore, see, P is fixed. Remaining 11 letters are there, in which repetition is there, right? P is only once, so all these repeated letters are coming in this. So in which what is repeating? D is 2 times, then E is 4 times, then N is 3 times. So in this 11, these are repeating. Therefore, what is the required number of permutations? The required number of permutations here is required number of arrangements also again. Okay, permutations is equal to, what is that equal to? That is equal to, so there are 11 letters, so it is 11 factorial divided by, what is repeating? D is repeating 2 times, 2 factorial, E is repeating 4 times, 4 factorial, and is repeating 3 times, so it is into it. Okay, simplify this, you will get the answer as 138600. Okay, this answer you get once you check what you get. Okay, so this is the answer where the permutations or the arrangements are there in the letters of the word independence, where it starts with the P. Okay, now the second one, do all the vowels always occur together? What is the meaning of that? Vowels are occurring together, remaining arrangements you have to find out, remaining letters. So how many vowels are there here? I is vowel, E is vowel, right? Only 2, correct? So it is I and those 4 E are considered together. Okay. Then the remaining, this is all together. Wherever together is there, the word, then it is always we consider all those together as one unit. So remaining, there are N, 3 N's, right? N is 3 times. Then what is that? D is 2 times. E we have taken. P is once. And C is once, right? So all these are taken as separate units. This is 1 unit. 2, 3, 4, 5, 6, 7, 8. So then therefore total 8 units are there. Therefore here the required number of permutations is equal to required number of arrangements also you can take. Okay, number of arrangements also you can take. Arrangements is equal to, what is this equal to? It is equal to 8 factorial, because 8 units are there. In that N is repeating 3 times, so we have to divide by 3 factorial. D is repeating 2 times, so we have to divide by 2 factorial. No other is repeating in this units, right? Separate units. But inside again, you have to multiply with these arrangements, right? Inside this, how many arrangements are there? See, there are 5 letters, so we can arrange them in 5 factorial ways, right? 5 letters are there, so we can arrange them in 5 factorial ways. Among that, E is repeating 4 times, so we have to divide it by 4 factorial. Okay, simplify this, you will get the answer as 16,800. Okay, simplify and try to get this answer. Clear? So next we will go to the third sub question, that is, do the vowels never occur together? See, what is the difference between this? These two are exactly opposite to each other, right? Here vowels are occurring together, but here vowels are not occurring, never occurring together, right? So how to find out the permutations? The required number of permutations, right? Required number of permutations you can find. Permutations is equal, or arrangements you can do. Permutations is equal to what? Total number of permutations. From the total, we are subtracting the arrangements where the vowels are together. That time we get the permutations where vowels never occur together. Okay. So the required number of permutations here is total number of arrangements or permutations. Okay. Total number of arrangements minus the arrangements where all the vowels are together. Okay. Vowels always occur together. Okay. So that is equal to, now see, total number of arrangements is how much? We got that as this one, 1663200, right? Minus the arrangements where all the vowels are together is this one, right? 16,800. So when you subtract this, you will get the answer as 16,46400. Okay, this is the required number of permutations in this case. Now fourth sub question. What is it telling? Do the words begin with I and end with the P? So I have to start a word begin with I, means here it is fixed. Beginning it is fixed. Then how many letters are there in between? There are total 12 letters. In that I and at the end, what is fixed? P, right? Here it is fixed. Beginning and ending fixed. Only the remaining total 12 are there. 2 went already. So remaining 12 letters, 10 letters are to be arranged, right? Among those 10 letters, whether repetition is there? Yes. See, I is only once and P is only once. So among these, all those, D is repeating 2 times, N is repeating 3 times, and E is repeating 4 times. So in these arrangements, all these repetitions are there. Therefore, what is the number of arrangements here? Therefore, I can write the required number of arrangements here is, number of arrangements is equal to, we should not consider that I and P remaining. So it is 10 factorial divided by 2 factorial into 3 factorial into 4 factorial. Okay, when you simplify this, you will get the answer as 12,600. Okay, this question is very important, practice well. The next problem. How many 6-digit numbers can be formed from the digits 0, 1, 2, 3, 5, 7 and 9 which are divisible by 10 and no digit is repeating? Okay? Now see here, 0 is there, so you should be very careful. Okay? So we want 6-digit numbers, so let me create 6 vacant places. Okay? So 6 vacant places we have here. Now see, we have to find from the 6-digit number using these digits which are divisible by 10. Okay? Divisible by 10 means we have to concentrate on the units place, right? When this will be divisible by 10 or the number will be divisible by 10, whenever the last digit is 0, means I have to fix this as 0 here, then only the entire number whatever I take here is divisible by 10, right? So 0 I have to fix here. So among these 1 went, right? Repetition is not allowed, therefore 0 I cannot consider in remaining positions. Now come to this position here, okay? In this position, how many possibilities are there to fill this? So I can fill this in how many ways? 1, 2, 3, 4, 5 ways, right? So this can be filled in 5 ways. The next one, repetition is not allowed, therefore the next place can be filled in 4 ways. The next place can be filled in 3 ways. And the next one in 2 ways and the last one only in 1 way. Therefore, how to find the number of arrangements? Therefore, by FPC, fundamental principle of counting, I can tell the total number of arrangements is equal to total number of arrangements or permutations of the canal. Okay, arrangements is equal to, what do you get? It is 5 into 4 into 3 into 2 into 1 into, here only one possibility, or you can tell it is fixed. So into 1. So it is actually equal to 5 factorial, and that is